Hi everyone, my name is Haley Metzger, and this week I will be going over problem number 2, part C from the Conservation of Energy Expert TA homework. So this problem states a brick of mass m equals 0.43 kilograms is set against a spring with a spring constant of K equals 622 newtons per meter, which has been compressed by a distance of 0.1 meters. Some distance in front of it along a frictionless surface is another spring with a spring constant of K equals 459 newtons per meter. And then part C states, now assume friction is present on the surface in between the ends of the springs at their equilibrium lengths, and the coefficient of kinetic friction is 0.5. If the distance between the springs is 1 meter, how far in meters will the second spring compress? So here is a picture describing kind of what I just read. So here is the block of mass at 0.43 kilograms. Here's the first compressed spring with the spring constant of 622 newtons per meter. That's compressed a distance of 0.1 meters. Here is the second spring that's not compressed that has the spring constant of 459 newtons per meter. Here's our positive x and y directions defined. Right is positive and up is positive. And then part C, remember that this has friction, so the coefficient of kinetic friction is 0.5 meters. The distance between the two springs is 1 meter, and we will be solving for the distance that the second spring is getting compressed. So some equations to keep in mind when solving this problem. The equation for the potential energy of a spring is 1/2 kx squared. When energy is conserved in a system, so when there's no friction, you can set this equation equal to each other. So it would be 1/2 k1 x1 squared equals 1/2 k2 x2 squared. But keep in mind that part C does have friction. So the equation for friction is F equals coefficient of friction times m times g. And then the equation for the work done by friction is negative F times d. So using these equations, we can kind of combine everything to make the equation that we'll be using. And this is 1/2 k1 x1 squared minus coefficient of friction times mgd equals 1/2 k2 x2 squared. And then plugging in the numbers that we have defined above is going to be 1/2 times 622 newtons per meter times 0.1 meters, and then that value is squared, minus 0.5 times 0.43 kilograms, and then our g value is the 9.8 meters per second squared times 1 meter for the distance between the springs, equals 1/2 times 459 newtons per meter times x2 squared. So that x2 value is what we're solving for right now. After you multiply everything out, you will see that you get x2 squared equals 0.00437, and then you need to take the square root of this value to get your final answer of 0.066 meters, and that is the distance that the second spring will be compressed. Some pitfalls to keep in mind when you're solving this problem. Be sure that you're using the g value of 9.8 meters per second squared and not negative 9.8 meters per second squared. This is because the negative value was already taken into account when writing the equation. You don't need to use it again. Also make sure that you're squaring the x values in your equation. So like up here, make sure that you're squaring this 0.1 meters value. And kind of on that same note, make sure that you're taking the square root of the x2 squared to get your final answer. So you don't just want to leave it at the 0.00437. You want to make sure that you're getting the square root of that to get your final answer. And as long as you're remembering those things and just using the equations, you shouldn't really have a problem. Thank you.